For the second set of data distribution, we will be using this data. This data being Harry and Ron went for a walk in the Forbidden Forest for 10 days in a row. Each day they counted how many dragons they saw. They saw 1, 2, 3, 3, 5, 6, 4, 3, 2, and 2 dragons. Create a data distribution. As we know, a data distribution is similar to a bar graph, but not. So how we'll start off is by creating a bar graph with the aspect of our x and y aspects, or y axes. We have x and y, and then we'll put in our points or our sections to represent all of the days. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this represents the days in a row that they went on their walks. And then on this side will be the number of dragons they saw, so we'll write that in, number of dragons, and then we'll start at 0 because they could have not seen any dragons, and go up by 1, and just go 1, 2, 3, 4, 5, 6 dragons. So then, now what we'll do is we'll fill in the rest of our graph almost as if it were a bar graph, but then at the end we'll see why it's not a bar graph and why it's a data distribution instead. So, for the first day, they only saw 1 dragon. So we go to the first day, and we go up, and we see that they saw 1 dragon. So we'll write that in. And then day 2, we see that they now saw 2 dragons. So we'll keep going up 1 more to represent the 1 dragon increase on day 2. And then day 3, we see that they saw 3 dragons. So we'll go up 1 more as well to represent the 1 dragon increase. But then come day 4, we see that they saw the same amount of dragons that they saw on day 3, which is 3 dragons, so we can create the same bar for that one. And then day 5, they saw 5 dragons, so we'll go up 2 more, because we're at 3, 4, 5, to show that they saw 5 dragons on day 5. And then day 6, they saw 6 dragons, and we know that 5 is 1 more than 6, and 5 plus 1 is 6. So now we're up to day 6, and then day 7, though, they only saw 4 dragons. So we go down from 6 to 5 to 4, and we follow the line across, and we see, and we write in our 4 dragons for that day. And then day 8, they only saw 3 dragons, which is 1 less than 4. So we go down. And then day 9, they saw 2 dragons, which is 1 less than 3 as well. So we'll draw that in. And then day 10, they saw 2 dragons as well. So now, what we have to do with our graph is determine whether or not it is right skewed, left skewed, or normal data distribution. And we know that when it is left or skewed left, that the data, the tail starts in the left area and most of the data clumps to the right. So we can see that although the data does start in the left, it doesn't end up clumping up top in the right-hand corner. And then for data distributions that are skewed right, the tail starts in the bottom right-hand corner, which in this case it could start in the bottom right-hand corner, but then it increases up and the data would then clump together in the top left-hand corner. But in this case, we see that there is nothing in either corner, therefore making it not being able to be skewed at all. So then that leaves us with one option, and that option being a normal distribution. And normally, like if a data distribution were to be normally distributed, it would need to be represented as a bell curve. And in this case, it can be a bell curve because a good portion of the data clumps together in the middle of the graph. So we'll draw in our bell curve by just going like this and creating a bell shape that you would see in a church or that would remind you of the Liberty Bell. It has the top part and it rounds out and it comes down. So then we can see that the data starts, one of the tails start in the bottom left-hand corner, goes up and it reaches its peak, and it comes back down to the bottom right-hand corner. So we know that our data is a normal distribution.